Hello and welcome to the video tutorial for WindowsSCOPE, an application that provides several useful tools for the analysis of Windows internals, such as kernel structures and memory management. It even allows you to perform graphical program flow analysis. This video will guide you through the basics of using the WindowsSCOPE tool. Start the application by clicking on the WindowsSCOPE icon. Once you have opened WindowsSCOPE, you will see the menu bar. It is important to note that if this is the first time you are running the program, you will have to enter your license file. WindowsSCOPE operates on projects. Click on Project and you'll have the option to create, open, or delete a previously created project. We will select Open. Pick the sample project, which comes compiled on WindowsSCOPE, and then click Open. You will notice 6 different tabs. Structure Map is the one that is pre-selected and allows you to navigate through your snapshot. With the project open, you can select which snapshot you would like to see. I will select snapshot number 1 for this example, and as you can see, there is some information displayed, such as the name of my computer, ExpressCard1. You can also see the operating system, memory size, and the system architecture. If you would like to see a snapshot of your own computer, click on the Fetch button at the bottom. Fetching is the process which WindowsSCOPE uses in order to capture everything stored in virtual memory. Once you click Fetch, you'll be prompted to select the type of memory you wish to fetch from. Select Direct from Virtual Memory and press Fetch. If you are following along, you should pause the video now while WindowsSCOPE performs the fetch. When the fetch is complete, enter a name for the snapshot and click Save. By clicking on the plus symbol, you expand the Memory View folder, which shows you 4 different subnodes. If we look at the OS Structure node, we will see a selection of some of the important Windows structures. For example, the System Service Descriptor table is a list of pointers to system calls exported by the kernel. Also, there is the Interrupt Descriptor table, which shows a list of pointers to interrupt handling routines. The Page table shows a page-by-page representation of virtual memory. Select a single page and its contents will display in the pane to the right. The Process table is a list of all of the processes which were running at the time of the snapshot. You can easily find changes between snapshots by selecting 2 different snapshots and clicking on Compare. This will automatically compare the snapshots and highlight in green anything that has changed. Now we will go back to the structure map and take a look at the Processes node. Pick a process and you will see that some of the modules contain code. If you click on the Investigate tab while this code is being displayed, by default, you will see all of the raw bytes of the process. To see the code in a more meaningful way, click on the Disassembled tab. Each line is an assembly instruction parsed from the raw bytes. After the address, instead of 16-byte words, comes the offset of each instruction in the section, the opcode, the operands, and the original hexadecimal code of the instruction from the raw bytes. A helpful feature of the Investigate view is the plus symbol on the side, which allows you to add a comment to each line. If you comment any of these lines, you will see the comment symbol at the beginning, and this X at the end, which allows you to delete the comment if you feel it is no longer necessary. If you would like to see only the lines you have commented, you can do so by clicking the Show Only Bookmarks tab. There is also a highlight button in the right-hand corner that allows you to see which instructions were actually in physical memory when the fetching process was initiated. These are the ones highlighted with the light green background. The instructions that were in virtual memory have a white background. Clicking the Graph tab shows a visual representation of the program flow for the selected module at the assembly level. These graphs sometimes take a few minutes to render. Once the graph has been generated, 2 panes are visible. The pane on the left shows a list of all of the procedures, and the one on the right shows the program flow. If you click on any of the nodes, you will also see the basic blocks within the procedure. Each block in the procedure graph is color-coded. This is the legend which explains what each color represents. There are 2 remaining nodes which can be expanded: Drivers and Summary of System Activity. The Drivers folder contains the drivers that running processes are currently using. The Summary of System Activity folder is just what the name implies: a summary of all of the open files, network sockets, and registry keys at the time the snapshot was being taken. In order to manage the snapshots you have taken, you can use the Configure View tab. Well, that about sums up the basic features. WindowsSCOPE is the only tool which allows you to fetch, compare, and graph multiple snapshots of your virtual and physical memory. Thank you for watching this video. I recommend you watch our other tutorials in order to gain a better understanding of all of the information you can get through our unique software.